All right, hello everyone. My name is Justin Huang, and I work with Maya Chakmak at the University of Washington. So my talk is about building web interfaces. And I wanted to explain just why it's personally important to me. So in our lab, we have a lot of undergrad researchers and more students who take our robotics capstone class as well. And so when all our lab computers are being used or when they want to work from home, you know, they can get some work done over SSH and stuff like that, but to use like these really awesome interfaces like RVs or RQT console or something like that, you pretty much need Ubuntu. And I've seen a lot of students struggle with installing VMs on their laptops, which are really underpowered, or they try and install Ubuntu on their laptops, but it's the wrong version, or they already have a different version of Ubuntu installed. And so I've seen everything, and I'm sure that people in this audience can empathize with that experience as well. The other thing is just, you know, our research is in human-robot interactions, so we really want to have modern interfaces for end users that work on all devices and which are easy to deploy. So the past, you know, we've always done demos and we've always had to haul around one of these Ubuntu desktops with us and a monitor to show RVs or something like that. And it's just not quite as convenient. So getting to some of the positive reasons why I think web interfaces are really great. Of course, it's cross-platform and it's cross-device, so you can use it on phones or tablets. I think a really important one is that there's a huge community of people who are very familiar with web development and in building really rich user interfaces with the web. And then on mobile devices, actually, you know, you'd be surprised to know about some of the app-like features that are out there. So you can add websites to the home screen, and so that when they open from the home screen, there's no browser UI. You can send push notifications to them, and you can configure them so that they'll load an app shell when the user is offline. And so they'll still see your app, just no data, basically. So here's an example of a web application that we developed in our lab that has been really helpful. This is just to show like how the web could be useful. So a lot of people spend you know, a lot of time debugging by typing ROS node list, ROS node info, ROS topic list, and so on. And this basically just puts it all in a web interface. So this is called the ROS Explorer. You get a list of nodes, and you click on a node, and you see the topics it subscribes to or publishes to. You click on a topic, you see the message type and the nodes that subscribe to it. You click on a service, you'll see the node that provides the service and the request and response definition. And if you like look for a parameter, you can see all the parameters. You can edit the parameter or delete it. Not sure if in the interest of time, I'm just going to move past that. But all right, so the outline of my talk, I want to talk about how we built some of these web interfaces with something called Web Components, and I want to talk about some ROS Web Components that we've developed. And I'm going to sort of interleave that with some more examples of web applications that we've developed in our lab using these tools. All right, so first of all, what are web components? So web components are a new HTML standard. They basically describe how you can define your own HTML element and put it in a web page. So this works natively in all the major browsers or with a polyfill, basically. So this is just what it looks like when you want to use a web component. So the first step is to add that polyfill just to make sure that you have all the features if the browser hasn't implemented them natively yet. The next thing is that you'll import a web component, the source of your web component. And then lastly, you can add it to your document. So a web component is basically just an HTML element. It may or may not have its own DOM. So in this case, I have an element called ROS WebSocket, which just is a wrapper around ROSLibJS, the ROS connection. So it has no DOM. But what makes it really useful is that these components can have internal state. They can have publicly visible attributes, or sorry, properties that you can get or set. And you can call methods or listen to events on them. So basically, they have like this public API and an internal state. So it's kind of like bringing object-oriented programming to the web, as it were. The title of my talk includes a reference to Polymer, although I realize it's actually not that important to this talk. So basically, Polymer is just a library for creating web components, and it also provides a declarative data binding syntax, which is also available in many other JavaScript frameworks. But the important thing is that you don't actually need Polymer or any framework at all to use web components, because web components are standard. So they're just part of the native browser API. But if you are going to use Polymer, then this is what it would look like to do some data binding. So in this case, let's say the user gets disconnected. I can show this dialog box. So I'm going to use two more custom elements called paper dialog and paper input. These are just like a dialog box and a text input, but fancy. And I'm going to bind the URL field of the WebSocket connection to the text input. So that might look like this. Oh, that's the binding right there. That's just their particular syntax for doing so. So it might look like this, basically. So whatever the WebSocket URL was before, it'll populate that text input field. And then if you type something different in the text input field, then it will update the connection. So it's just a two-way binding, and you don't have to write any JavaScript to do that plumbing. Just another example I wanted to show. So I have another element called ROS topic. So you can say topic equals some topic name, in this case clock, and then you can bind whatever the most recent message that was received on that topic to a variable called time. And then, and this sort of shows that you can do data binding with not just primitive types like strings or numbers, but you can also do it with objects or arrays or whatever. And you can also take these and put them in your DOM directly. So this is what that might look like. Oh, I keep on forgetting about these boxes. All right. So this is what that might look like. It's not a very exciting demo, but basically you can subscribe to a topic and just plop it into your DOM. And you don't have to write any of that plumbing once again. Okay, so as you've already seen a couple of ROS Web Components, so we've written more of them, and you can find them online at this website called webcomponents.org. And if you just search for ROS, you'll find all of them. And if you click on any one of those links, you'll reach a documentation page where you can see some sample code and some documentation on its API. And so you've seen that most of these elements are pretty simple. They're really just wrappers around ROSlib.js, like ROS topic, ROS service. But there are a couple of more complicated components that you can integrate into your app that really, I hope, will provide a lot of value. So the one I want to highlight in particular is this element called ROS RVs. So I'll show that to you. So this is what ROS RVs looks like. Basically on the left you have displays, and so I can add a display like a grid. I can reconfigure the display dynamically. So here, and I'll just say also, it doesn't implement all the features that regular RViz does, and it's probably buggier too, so I don't recommend using it in production, but I hope that people will experiment with it and send issues and pull requests and so on. But yeah, you can reconfigure the display really easily. You can also do it programmatically, which will be shown in this video later. We've got interactive markers, so this is a really easy way to just add some interactivity to your web page. You can check and uncheck displays to show and hide them, and so on. And then we've got the config. So as you modify the displays, the config automatically updates, and you can view the config or load a new config. So in that case, I just pasted in an old config that I had. And then because it's a web component, you can call methods on this web component to dynamically update the display. So in this case, I'm just reaching into the DevTools and calling methods to show and hide these markers in the display. All right, so basically I want to talk about a couple of patterns that we've used to make another application. So first of all, you can use web components like ROS RVs, and I'll talk about these two patterns I found were useful. So we made an application called Rapid PBD, which is a programming by demonstration application for the PR2 and the fetch robots. So this kind of looks similar to the previous video But what's different is that actually ROS RVs is just one part of this larger interface. So there's this whole configuration of like what the robot should be doing. If you look at the top, there's like a list of steps, and you can walk through the steps and preview what the robot would look like at each of those steps. And so it's very easy to just plop an RViz element in there and to dynamically configure it based on the needs of your application. I want to talk about the reactive database pattern. This isn't strictly necessary, but I found it to be very fun. So basically, the insight is that if you think about how you might implement a database on a website with ROS, you might, if you want to get something, you might have a service that takes in an ID and then it returns the data. And then you might have to like periodically call this service or something to check if it's been updated. But actually what you can do instead is that you can just subscribe to a topic and get the data on the topic. And so that way, whenever it changes, you get the latest data from the database. And the secret to doing this is that you need to use a latched publisher. So a latched publisher is one in which the latest message that was sent on the publisher gets saved. And so anyone that subscribes later will get the last message that was published. And so, so here, for example, if I have a database and I want to edit some piece of data, or I'm updating a piece of data, I'll do my actual database with like MongoDB or whatever. And then if I don't already have a latched publisher for this particular item, I'll create it. So I'll create a publisher to /program/59B9A, whatever the ID is. And I'll be sure to make that a latched publisher. And then I'll publish the data out. And then so again, the way that clients will get the data is that they subscribe to a topic. And actually, instead of having a callback and re-rendering, I'm actually going to use data binding I'll just show you how you can use data binding to go all the way from the URL down to the view. So here, I'm using a web component called app_route, which basically just parses the URL. So in this case, I'm going to parse an ID out of the URL and save it into this variable called route data. Next, I'm going to configure, or my ROS topic is automatically configured to subscribe to /program/ and then whatever the ID is. Okay, so that just comes from the URL. And then it's subscribing to this topic, and we know that the data is being published on this topic, so whatever the last message is, it will end up in this program variable. And I can pass that program variable into yet another web component that is responsible for doing the actual rendering of the view. So this is a video of kind of like what the consequences of a reactive database looks like. Here I have two browser windows open, and all the changes that I make in one window are being reflected in the other window. So it's kind of like a Google Docs kind of experience where you're seeing updates happen live that are happening in another client. So this isn't like a screen mirroring thing or anything. This is just using ROS to do reactive database stuff. So, for example, I'm deleting a step in this window, and then actually I'm going to go back and I'm going to actually delete one of the programs, and you'll see that both of them get deleted. So that's the power of a reactive database. You can get like these cool dynamic updates between multiple clients. The other pattern I wanted to talk about is what I call the user event pattern. It's not necessarily new, but I thought it was useful for us. So basically the way that this works is that your front end, instead of doing any actual work itself relating to calling out to the database or whatever, whenever the user like clicks a button or does something that modifies your data, it just publishes an event that describes the change that happened. And then it's up to the server to interpret that event and modify the data. And then if it has a reactive database in it, then it will republish the data back to the clients. So the main reason why you might want to do this is if you're doing like some human-robot interaction research and you want to do a user study or something. It's very easy to basically record all of the front-end interactions that happen just by using ROS bag on this events topic. So just to put that visually, let's say you have your browsers here, and I'm in one of these browsers and I'm editing a program. So I click a button that says Add Step. So this will generate a message called User Event, and it will have some information that says, like, add a step to program 59B9, something, something, and then it publishes it. The server gets that, and then it does its update, and if it's using the Reactive database, it will republish the updated program back out to all the browsers. So that's how you can get something like what we saw in that video earlier. Okay, so I'm not actually going to go through the quick start because the slides, I believe, are all going to be available on the ROSCon website later. But this will just take you through, like, if you haven't ever worked with Node before and you need to install Node, like, this will take you from there all the way to, like, creating a project, downloading the components, and basically creating, like, an instance of ROS RVs and a full screen on a web page. And there's also a note for React users. It's a little bit inconvenient. Some links to all the stuff that I showed, including some web projects that I haven't talked about in this presentation. I also wanted to show that this wasn't just like a research project that stayed in the lab. We actually used this for real to program the fetch robot. So we had 2 months ago a group of high school students, and they all had a wide range of disabilities, basically. And we did a week-long programming workshop with them. So they used a web-based coding interface as well as rapid PBD to program some arm motions for the fetch robot. And so they programmed the fetch to do some tasks in a simulated grocery environment. And so that was a lot of fun. It was very important that they were able to use their own laptops because they have their own accessibility settings and configuration. So anyways, I hope that this talk shows that using the web can be a really powerful way to develop interfaces for robots, and I hope that the next generation of robot interfaces are all built with the web as well. So thank you very much.
All right, we've got time for a question or two. David?
This is brilliant. Do you have, or what, in ROS RVs, what is the rendering engine that you have? Is it the lib3d.js or something else?
It is ROS 3D.js. So everything that is in there is basically kind of like a wrapper around ROS 3D.js. It's all stuff that you could program yourself. The main thing is that you're just dynamically able to add stuff and remove stuff at runtime.
Awesome.
Yeah.
I just have two really quick questions. Also, I think this project is amazing. Have you done any testing on what happens when a user deletes data from the database that another user is working on?
That's a good question. I think basically, like, I avoided that in that video that I showed you. But basically nothing would happen. So in fact, the second user might reinsert it as a result of that. So like, okay. When you see me like delete a program and then you see the two lists of programs get updated, sorry. What's actually happening there is there's a separate state that is just the list of programs that's available. So that's what's getting updated.
Okay. And then the last thing was, have you done any sort of performance metrics on like how fast you can pub and sub from inside Polymer versus just straight JS talking to ROS Bridge?
No, I haven't done that. I suspect it's not that much of a difference. Okay. It just depends on how Polymer is implemented, I guess, and how much copying or something it does. But okay. I use ROSLibJS internally, so yeah.
Cool. Thank you.
Thank you.
All right, thanks. Thank you very much.